Yes. Okay, that turning pages, please, I can hear you.
Okay.
Okay, this is what we'll do today. We'll go over the homework in detail because Maureen sent me homework, Mercedes sent me homework, and I see that you're still having some problems with some of the topics that we'll go over. Okay, so we'll do the homework, and we'll do some more probability, and probably won't get the combinations and permutations. Probably get to that on Monday. All right, so let's go to our homework first. So let me.
Are we getting any holiday? No?
Well,
Yeah.
we will. Well, remember, we are on through the last week of July,
Okay.
and then we are on break until we start back in the fall.
Okay. All right.
Okay, I
Yeah.
don't know the extent of that break. We'll find it. Normally, we come back like a week after Labor Day, but that was in the past, so I don't know. We'll hear later from Diane Lord. She's the manager of the program. All right, but we will go through the end of July, and then we'll be on summer break. All right. So that doesn't
Okay.
leave too many more weeks. I mean, at July 7th,
Well, I mean, 3 more weeks, Miss Barbara.
yeah, let's see, 21, 28. That's right. 3 more weeks. Week of the 7th, and then next week, the 11th, and we'll have the 18th and the 25th. So next week, and then 2 more weeks. All right. Okay, let's go over number one. Maureen, you want to read number one? What does it say?
35.
Simplify.
Parentheses 4 x to the power 3 multiplied by
You don't,
ax.
oh, so you don't see the minus. You don't see the minus 3. Let me make that bigger. You didn't see the minus 3.
Yeah, or minus 3.
Did you see it when you did the problem?
I'm sure.
Because you said 3. And I'm wondering if that's why you didn't get it right. Okay. Simplify the expression 4x to the minus 3 power times 8x. Now, does anybody remember what I said about the negative exponents? When you have a negative exponent, Mercedes, what is that equal to?
Negative exponent.
What does that translate to? In other words, this 4x to the minus 3. Let me just copy that. What is that equal to, Mercedes? Remember I gave you a rule with negative exponents. Remember what it was?
1.
No, that's not it.
Oh,
I didn't say 0.
I know.
Anything to the 0 is 1, but I didn't say 0. I said negative, right? Maureen, you remember what I said about the negative exponents?
No.
Alba, do you remember?
Negative is go with the
Think of something you always say. What do you say to do what?
you flip it.
Yes, you flip it. Flip it and make it positive,
Yes, ma'am.
right?
Yes.
Flip the negative and make it positive. So that's 4x to the minus 3. That becomes 1 over what, Mercedes? What does that become?
1/8.
No, we're only talking 4x to the minus 3. So what does that become? When we flip it, the 4x is now in the denominator, right? So this is 4x.
Divide.
No, this, we already have a division now, 4x, and this would be to the plus 3, right?
Yes.
There we go. Let me make this bigger and then put it closer, because I want to make sure you understand this rule. This is very, very, very important. Okay, so let me just bring that over. Okay, here we go. So, Alba, your famous flip,
Yes, Mom.
right? When you have a
Yes.
negative exponent, you
You
flip
flip
it
it.
and make
Yes.
the negative positive.
Yes.
Everybody understand that?
Yes, Mom.
Mercedes, question?
Yes, I remember Miss was right now. You just saying I didn't even catch up on myself. That's what you're asking. I was
Right.
thinking that's what I really
More,
remember that part.
you remember that rule? Maureen, you remember?
Yeah, and write it down in the house. So don't forget.
Yes, when your exponent is negative, you flip it and make it positive.
Mm.
So this is 4x to the minus 3 over 1. Now the 1 is the default, right? I
Yeah.
mean, but it is over 1. Let's just put the 1 there. So, okay. And let's put the 1. Now the 1 is the default, so you really don't have to put it, but I put it there so you can see it. It's 4x to the minus 3 over 1. When you flip it, the 1 is now in the numerator and the 4x to the third is in the denominator. But now this is positive. All right?
So you're saying when exponent is negative, you flip it.
Make it positive.
That's it. Flip it and make it positive. Mercedes, is that clear?
Yes, ma'am.
Okay, so that 4x to the minus 3 becomes 1 over 4x to the third. So let's just put that here and multiply it by 8x. See if you can tell me now how you do it. Okay, let me just take this, let me just put that on the other page so you can see it.
And
Okay, now I'm over on the other side. Mercedes, are you up with me?
Uh,
Because
I don't.
I'm on the other side. Sometimes with your phone, you have a problem, right?
I'm not seeing what you
You're
wrote.
not seeing on the right, this, I just put the simplify again there.
Okay, okay. You put it
Okay,
on.
right,
Okay.
because I want to put this on the other side. Okay. All right, so we have flipped it. And now we have what we'll put here. Okay. Okay. So let me take the numbers out. You don't need these numbers. You don't need that 2. And you got the 1. Let's put the 1 here. Okay. You don't need the, I'm just repeating what I had on the other side of what we got when we did the flip. Okay. Take that out. And take that 2 out, because it's renumbering and we don't have to do that. And take this 2 out. So we still on number 1. All right. Now this will be times 8x. So let's just put the time 8x here. Does anybody see the answer?
okay, time 8x.
Okay. So we multiply 1 over 4x to the third times, put that there, times 8x. Okay, so let's bring that up. Okay, now, does anybody see the answer?
1 to the 4x.
So that 8x is now in the numerator, right? 8x times 1 is just 8x. So let's just put 8x here. So this will be 8x in the numerator. And in the denominator, we have 4x to the third. Now, what does that really mean, Maureen? 4x to the third. What do you do with the 4x?
You multiply it 3 times?
That's right. You multiply it 3 times. And what do you get?
64.
And what do you get for the x?
64x.
Well, when you have the third raised to the third, you're raising everything in the parentheses. So you'll have 64.
Uh-huh.
And the x is also raised to the third. So you have x to the third, right? Everybody with me?
Yeah.
Okay. So this is what this becomes. 8x over 64x to the third. Now, Mercedes, can you see your answer now?
X.
Well,
What does this simplify to?
I simplify to see. I'm sorry, wait, I'm sure can you bring the answer a little bolder, please?
Oh, no, I had the answer anyway. I changed it.
Okay, here we go. Let's make those bigger. Okay, here's the answers, all right?
Okay.
Now you see the answers. And I
So-
ask you, 8x over 64 x to the third. Now, what's the common factor, Albert? What's the common factor with 8x and 64x to the third? What's the common factor with these two terms?
It would be 2.
No, 2 would be 1, but what would be the greatest common factor?
Oh, okay.
In other words, I'm asking what number, what's the greatest expression? And here you got a variable and a number. You can divide into 8x and also divide into 64x to the third.
8 and 4.
No. It's only one number and it's one variable. So what do they have in common? They have an 8 because 8 goes into 64 8 times, and they have x in common, right?
Yes.
Okay, so if you, let me just put here, if you divide this by 8x, right, and you divide the denominator by 8x, let's just, okay, by 8x. That's the greatest common factor. What is that equal to, Alba? Let's take the first one. 8x divided by 8x is equal to what?
I would say 4.
No, 8x divided by 8x. Remember,
One.
one. That's right, Alba. One.
Yes, 1.
Any number or any
Yes.
variable or
One
any
time.
number variable combination divided by itself is just equal to 1.
Yes.
All right. Mercedes, what's 64x to the third divided by 8x?
That's 8. Hold on.
Let's take them one at a time. 8 and the 64 goes how many times?
8 times.
8 times. Very good. So that would be 8. Now let's take our x's. The x term. X to the third divided by x gives you what?
8x.
No. We're only looking at x, Mercedes. X
One.
to the third divided by x to the 1 is what?
X to the third. Oh, you're saying x to the third divided by
X to the 1.
That give you eight eight x
No,
to
no,
the
I'm not saying 8 now. You've already divided the 8 into the 64 and you have 8. Now I'm
8.
asking you x to the third divided by x to the 1.
oh give me x to the fourth power.
No, the third.
This is a division. Alpha, what do you do when you're dividing
One.
exponents? What's the rule when you're dividing? You subtract the exponents.
Yeah, you subtract the exponent
Right. So
from
what
the
is the 1? The 3 minus 1, Alpha, is what?
2.
2. So this will be x to the second.
Yes.
Mercedes, you following me?
Yes, yes. Sorry.
Yeah, you were doing multiplication. And that's when you
Okay.
add the powers, Mercedes. But this is not a multiplication. This is a division. Go
Okay.
back to your exponent rules. Multiplying exponents, you add the exponents. Dividing exponents, you subtract the exponent of the denominator from the exponent of the numerator. So this will be x to the 3 and then x to the 1. So it'll be 3 minus 1, and that's equal to 2.
I didn't say that ask to you, Miss Barbara.
I'm sorry, what did you say?
I didn't say I explained things to you. But you tell me you tell me I had it wrong, man. Sure.
No, you didn't send me that. I'll tell you what you sent me.
Tell me what I sent you then. I explained how
Okay.
to see.
Number 1, you sent me D. Wait, just a minute. You sent me D and you sent me A.
Okay.
Second go round, you said A.
So it would
Okay.
be B, Miss Barbara? Would it be B?
No, is that 1 over 8x to the second, Alva? Which one is 1 over 8x to the second? A, B, C, or
1
D,
over
Alva?
8x to the second is C.
C, that's right, Alva. The
Okay.
answer is C.
Okay.
Now,
and it has-
Maureen, maybe you planned to put it there, but you sent me D
Yeah.
and you sent me A.
Oh,
All right.
so I know it has C, but I must have messed up putting C there.
Well, that's what I'm saying. Sometimes you make a mistake, but I'm just saying what you text me. And I
Yeah.
wrote it down. You sent me D as your first answer, and then you sent me A as the second go round. Okay, so like Alba said, the answer is C. Any questions on number 1?
No.
Well, I would say, you know, it's hard to stick, Miss Barbara, but anyway.
But remember
Wait.
now, this kind of exponent problem is testing your knowledge of the rules.
Yes, the
Right?
rules. Yes.
Because remember, I gave you a sheet of exponent properties with product and quotient. Quotient is division. Subtract the exponents. Multiplication, where you get a product, you add the exponents. If the exponent is negative, flip it, make it positive.
Yes.
Those rules, be sure and keep those rules in mind, all right? Don't forget those rules because you'll apply them to any exercises we do on exponents. Mercedes, you think you can do one like this again?
I try, but I got it right. I look at it and think and says,
Yes, you had it right. Mercedes had C. Mhm. How did you figure it out, Mercedes?
what you call it now? We don't use any pen and paper. Mental math. I look at it and I say, oh, take away 1 from the 3x, the 3 power, and I got 2, and I'm keep looking at it and says, oh, it's C. I did go as far as multiply and get 64. And then I looked at it again and says, oh, then you're going to take away 1 from the.
Okay, all right, because 4x, if you take 4x to the third power, because from 4x to minus 3 becomes 1 over 4x to the positive 3. And 4 times itself 3 times. 4 times 4 is 16, times 4 is 64. And 64 divided by 8 is 8. All right, Mercedes, good figuring it out.
Okay.
Now,
Okay.
Alva, scientific notation. Let me bring this one to the next. See if you can tell me this one, Alva.
Four,
We want to express,
four.
that's 45 million. And we want to express it in scientific notation. That's a number times 10 to a power. So which one would you say, Alva? Now the decimal point is right here, and you're gonna move it to the left, and you know it's between the 4 and 5 because you see what they have here, right? So
Yes.
what would be the answer, Alva?
Now you're gonna move it between the 4 and the 5.
Right.
Okay.
What's the answer?
All right. So. 1,
And the exponent represent the number of places you
1,
moved it.
2, 3, 4,
So what's the
5.
answer?
Would it be 45 to?
No, you have to have a number between 1 and 10. Can't be 45. So you can eliminate A and C because the first number has to be less than 10. So A and C are greater than 10. They're 45. So you can eliminate A and C is between B and D. Which one, Alba?
I would say B.
How many places did you move it?
You move it.
Just count the zeros and to the 5. So how many places?
Okay. 1, 2, 3, 4
Just-
places.
No. You have zeros. You have 6 zeros, and then you're gonna
Are
put
you
it
moving
right
it?
here.
You're moving it to the left.
You're moving it to the left between the 4 and the 5. So how many
Oh.
places is that?
Okay. 1, 2, 3, 4, 5, 6, 7 places.
7. That's right. You just say 3, 3, 1, 7.
Yes.
So
7
the
places.
answer D, right?
Yes. Okay.
Answer D.
All right.
Oh.
So
Question.
let's try that one again, Ms. Bauer.
Okay. Now,
Scientific notation.
right. Scientific notation, you have 2 numbers. One is where that occurs after you move the decimal point. The other is 10 to a power. All right.
Yes.
Now,
Yes.
the number that the first number has to be a number less than 10. That's why I
Okay.
said you could eliminate the 45, A and
Yes.
C.
Yes. Yes.
So now you're only looking at B and D. Now
Yes.
it's times 10, and you look at the decimal point is after this last 0,
Right.
right?
Yes.
So all you have to do is just count 3, 3, 6, and then between the 4 and 5 makes 7. So your
Yes.
power is 7.
Okay.
All right.
Okay. Yes.
So when you count, you just look at the digits. There's 3 digits here, 3 digits here. That's 6, and now
Oh, and
it's between the
7.
4 and 5, 7. That's how you get the
Yes.
7.
Okay. So
Got
let's try. Excuse me. Let's try. A. Why it couldn't be A? Because they give you 7 too.
Yes, but
Yes.
remember I said the first number has to be less than 10. That's a 45.
That is more than 10.
Remember, Alva, I said it has to be less than 10. 45 is greater than 10.
Okay.
That's why it can't be A.
Yes.
All right.
Okay.
Excuse me a minute. I've got to turn the timer off. Hold on. Okay, I'm back. So Alva, you understand now why it can't be A?
Yes, Miss Barbara, yes.
Tell me why it can't be A.
You say it has to be less than 10,
Yeah, the first number has to be less than 10.
than 10.
And that's a 45. That's greater than 10.
Yes,
Got it?
yes.
Any questions on converting regular numbers to scientific notation?
No, miss, thank you.
Okay. Now that was a big number, 45 million. Let's take a smaller number. Okay. And you tell me, what is this number? 0.00086. Maureen, what would that number be in scientific notation? Maureen, are you there? Maureen?
Did you hear me?
No, I didn't hear you. What would this number be in scientific notation? What would that be equal to?
0.86.
You giving me the notation, scientific notation?
Yeah.
What would it be?
1, 2, 3, 4. 0.86. That is 10 power 1, 2, 3, 4, 5.
Say it again.
0.86 multiplied by 10 to the power 5.
No. What would it be, Mercedes?
I think it is 8.6.
8.6. That's less than 10. So there's the first number, Maureen. Remember, the decimal point is here. You're moving it to the
Oh,
right.
yeah, the right. Oh, yeah, the
So
right. Yeah.
8.6 less than. So what's your second number, Mercedes?
My second number,
10 to the what?
10 to the fourth power. 5, sorry,
10 to the what?
fourth power.
What is it, Alva? 10 to the what?
Fourth. 4.
No, that's not correct. Alva, what's the number?
It's moving to the right this time, Miss Barbara.
That's right. So what would be
Yes.
the exponent?
1, 2, 3, 4, 5. X to the 5th power. 10.
No, that's not right. Maureen, what is the number?
Let's see, go to the right.
And you're checking from the point, right, Miss Barbara?
Right, I'm moving from the decimal point here
Yes.
to between the 8 and the 6.
The
And if
first power.
Oh, the 8 and the 6. Okay.
but if
The
I
first
move
power?
to the right, the power is negative.
Yes.
Now say
Oh.
these negative.
Yeah, that's with my sign. I'm so disappointed in myself.
So it's the 4th power.
Negative. Nope,
The
not the
fourth,
4. That's
negative
not the
4th
same
power.
as positive 4.
Yes.
When you
Fine.
moving that decimal point to the right, see this number, these numbers are less than 1. When you have a number less than 1, you'll have a negative power because
Oh, I
you're
see.
moving to the right.
Yes, it's true. I might remember my sign.
Yes, those are very important, Mercedes. A 4 and a negative 4, not the same. Questions?
No.
Yes.
So if you have a number less than 1, you'll have a negative power. Got it?
Yes.
If this number, let's just take okay, Alva. Let's take, I'll stay with my 86. I have 8, 6. What is that equal to, Alva, in scientific notation?
Okay, I have 8, 6.
Give me the first
Ah.
number less than 10. What would that be?
The first number that's less than 10 would be 8.
You're gonna throw away the 6?
Okay, so it would be 86.
No, 86 is greater than 10. Your
Okay.
decimal point is
Okay,
here.
it
Where you
would be
gonna-
6. It would be between the 8 and the 6.
That's right. So that would
Yes.
be 8.6. That's
Yes.
correct. And then
Yes.
your next number would be 10 to the what?
Okay, the next number
How
would
many
be,
places did you move it?
you move it 2 places.
No, you went from
Four.
the last 0. Maureen, I am talking to Alpha. Thank you.
Okay,
Say
yes.
here we go.
Your
So-
decimal point is right here, Alva, and you
Right.
moved it how many places?
You move it 1, 2, 3 places to the right.
No, 3 places will be between the 6 and the 0.
4 places, Miss Barbara.
That's right. You're moving to the
Four-
left. So it's
Yes,
here.
4 places,
So
and
you-
it is negative.
No,
No, pass.
positive.
Because it going to the right?
Left.
No, you at the right going to the left.
Okay. At the
Okay.
right, going to the left, yes.
So this would be to the +4.
Okay.
The way to remember this, if you have a number less than 1,
Yes,
you have a decimal number. So the decimal numbers would have negative exponents.
yes,
If it's not a decimal number, it could be a whole number and a decimal, and it will be a positive number. But if it's all decimals, your exponent will be negative.
yes,
You got it?
yes. Okay, so we move it 1 place to the right.
No, right here you move 4 places because the decimal point is after this last 0. So you move 1, 2, 3, 4. You just
Okay,
count the 3
yes.
zeros and the 6. That's 4 places.
Yes, okay. So
You know-
the exponent would be a +4.
That's correct. And that's why I kept 86 here to show you that when you had a decimal with the 86, you got a negative exponent. When you have
Yes,
a number greater than 1, like 86,000, you have a positive
Positive.
exponent that represents the number of places you move the decimal point to the left. So here you move to the left, here you move to the right. Got it? So
Yes, Miss Barbara.
all of your scientific notations have 2 numbers, a number less than 10, and then 10 to a power. 2
yes,
pieces, always. Number less than 10 times 10 to a power. That's the format. Got it?
yes,
Yeah.
ma'am.
Okay, that was number 2. Okay, now let's go to, now Maureen, you didn't do this one. Why?
Get that figure out.
Why didn't you figure it out? Okay,
Simplify the
4
following.
to the 3rd. What is 4 to the 3rd, Alba? What's that equal to? What does that really mean? 4 to the 3rd. What does that mean?
You're gonna multiply it 4 times. The 4,
You're gonna multiply the 4 how many times?
4 times.
That's not a 4, that's a 3.
Oh, I'm sorry. Yes, the 3 multiplied by 3 multiplied by 3.
No, 4 multiplied by itself how many times?
4 times. Oh, 4
No.
multiplied by 4 multiplied by 4.
Yeah, 4 multiplied by itself 3 times, right?
Yes,
So this
yes,
is equal to 4 times 4
yes,
times 4.
yes, yes, ma'am.
What is 4 times 4 times 4 times 4, Alpha?
Four.
Mental math.
4 times 4 multiplied by 4 multiplied by 4. 16, 32? No?
No, what's 4 times 4?
4 multiplied by 4 is 16.
And what's 16 times 4?
16, 30. 16 multiplied by 4 is 64. No.
64. That's right.
Yes.
64.
Yes.
Because
64.
the 32 is when it's multiplied by 2.
Yes,
So your double it is
64.
64. Now
Yes.
let's take the 3 to the second, right?
Yes.
Now 3 to the second. What's that equal to, Alva?
3 to the second power.
That would be what? Expanded. What would it be?
9.
Yeah, 3
is
times
9.
3. Yeah, that's right.
Yes.
It's 3
Yes. Equal
times
9.
3
Yes.
equal 9. So all you need to do is put these together, right?
Yes. Ma'am.
64 times 9.
Yes.
Okay, Alva, what's 64 times 9?
Okay. So tell them, Miss Barbara.
What is that equal to?
4.
That's your answer.
9 equal 576.
576. Mercedes, congratulations. You had that one right.
Thank you, Miss.
That's
What-
nice.
Yes,
the last
Mercedes
one?
had it correct.
But
Now-
I didn't do it, Miss Barbara. I caught up in some thing, you know, I have some men working at the house.
Yeah, I
I didn't
understand.
get to do it, yeah.
But Maureen, what was your problem on this? You said you didn't follow. What was the problem, Maureen?
I don't know.
Well, you know, when you see a number raised to a power, it's the number by itself, that number of times it represents the power, right?
Uh-huh.
And so you just expand the 4 to the third. You get 64, 4 times itself 3 times, 3 times 3, you know that mathematics is 9. Then multiply those two numbers.
Oh,
And that's your answer.
Miss, I remember the last one you did.
Okay, very good.
4.
Mercedes, I'm really proud of you, got that one right. Okay, 576. That's the answer that goes in the box. Questions on number 3. Okay, now number 4. Now, Maureen, Mercedes, what happened on number 4? You both had it incorrect.
Oh boy, I don't know.
Now that's a division. Did you see that as a division?
Yeah.
Oh, you did. So you know, okay, so that wasn't your problem. You knew it was division, right?
Mm.
So what's the rule when you're dividing exponents? Let me take this to the next.
You multiply.
No. What's the rule when you're dividing? What do you do
Add.
to the exponents?
Add.
No,
You flip the
no flipping. What do you do to the exponents when you're dividing? You subtract.
oh Lord.
Subtract the exponents, right?
Oh, I forgot.
Remember, you gotta know those rules.
Oh,
So you divide in 5x to the third by 2x to the second.
X.
So you're gonna subtract the 2 from the 3 and you get a 1,
Yes.
right?
Yeah.
And then 5 over 2 is just
Okay.
5 halves.
Yeah.
So what is 5 halves equal to?
Okay, excuse me, Miss Barbara. You say you're gonna subtract the 2 from?
The 3.
Yes, okay.
And that gives you just x to the 1
Yes.
or just x. When the power is 1, it's a default. So what you're left then with is what? Let me just write here. You have 5 and over 2. Let me just put this here on the line. So 5 divided by 2. Let's put the 2 here. Right? And I'll make that bigger.
Okay, subtract the 2 from the 3, leave 1.
Okay.
And
So,
5.
so you have 5
5.
halves, right? And the x to the 3 divided by x to the second is just x to the 1. So what you really have is, let me just put that a little closer. what you have is this whole expression, right? Times X. You understand why we have X?
I don't think I catch you right there.
5 divided by 2 is 5 over 2. X to the third divided by X to the second. Let me just write it over here. Okay. X to the third. Let me just put the 3 there. So I have X to the third. I'm just breaking it down separate here. On the line, divide that by X to the second. So let me just put X to the second. And what is that equal to, Mercedes?
X to the second.
X to the third divided by X to the second. What is that equal to?
1.
Well, X to the 1. Right? X to the 1. So that's equal X to the 1. And I'll put the 1 here, even though the 1 is a default. You don't have to put it, right? So that's how I got the X right here. 5 over 2 is just 5 over 2, or 5 halves. X to the 3 divided by X to the 2 is just X to the 1, which is just X. Now, do you see your answer there, Alba?
Is it D?
5 over 2 X?
Oh, yes, yes, Miss Barbara, I saw it.
What is the answer?
It's 5 over 2. It could be 2.5x.
That's it, Alba. Very
Yeah.
good.
Okay.
And because 5
Yes.
halves is 2.5, and
Yes.
that's 2.5, right?
Yes,
So
so it's A.
answer A. Very
Yes,
good.
yes.
I'm sorry, Miss Barbara, but I don't understand what you're saying. 5 off, something like that. I don't understand you get the rest of it. I understand you subtract the exponent.
Okay. But you don't understand how 5 halves is 2.5?
I understand how you get that part.
Okay, when you divide 5 by 2, Mercedes, what do you get?
Oh,
Mr. Math, what do you get?
2 under 2.1.
No. 5 divided by 2?
2 into 5 goes 2 times and 1.
And then 1 over 2, you mean?
Oh,
Right? Isn't it?
yes.
Half of 5 is 2.5. 2.5 plus 2.5 gives you what, Mercedes?
5.
5. Yeah, so half of 5 is 2.5. And 2.5 is 2.5, and that's, so you could have 2 and the fraction, right? But that's also equal to 2.5 as a decimal, correct?
I understood that.
You got it?
So I should have divided 2 into 5. Oh,
But that's what it says up here. 5x to the third divided by 2x to the second. So you take your coefficients and divide them. That's 5 halves. That gives you 2.5 or 2.5. And then you take your x to the third divided by x to the second, get x to the 1, put them together, you got 2.5x. Questions?
no, it's got you.
You see, it can't be any of the others because this says 5
Okay.
halves x to the 5th. They added the 3 and the 2, but you add when you multiply, not when you're dividing. You add the exponents when you multiply. Got it?
Yes, thank you.
And excuse me, Miss Barbara.
Yes, Alba.
You have to divide the 5 divided by 2, because if you do it the other way, you get a different answer.
That's right. You have to take the coefficients, Alba, and the
Yes.
coefficients are the 5 and the 2.
Yes.
Divide those out, you get the 2.5. or 2.5. Then
Yes.
divide the exponents. X to the third divided by x to the second is x to the 3 minus 2, and that's x to the 1.
Yes.
So there's your x to the 1 or x. Put the two together, you have 5/2 x or 2.5 x.
Yes.
Got it?
Yes, ma'am.
So when
It's
you,
just how to write it, miss. So
what is it, Mercedes?
like how to write it when you get the answer.
Excuse me, Miss Barbara.
I'm sorry, Mercedes, what are you saying?
I was saying it's just how to write the answer down.
Yeah, well, if you have multiple choice, you have to pick an answer that matches your answer. If your answer doesn't come out in the match one of them, you say, well, can I translate that to something else? In other words, once you got the 5/2, you said, oh, well, I've got an x here. I only see an x one other place, and that's my D, right? But it can't be of 3 because 5/2 is not 3. So it's got to be A. You follow? Once you get the x, once you get that variable right, now you can eliminate B and C. It's got to be an x because 3 minus 2 is just x to the 1. So between A and D, and 5/2 is certainly not 3. 5 minus 2 is 3, but 5/2 is not 3. It's 2.5.
So the answer is A, miss?
The answer is A.
Oh, I thought you said the answer was
Excuse me, Miss Barbara.
No, I
did you-
have it right here. Answer A.
Oh, I didn't see it. I didn't see that part.
Yeah, you see it right here. Yes, Alva.
Oh, did you send it to my email?
What, the homework?
Yes, this.
Yes, I did.
All right, okay.
Did you get it?
I didn't check to see. I will check it when I finish.
Yeah, I send the homework to everybody.
Okay.
Okay, so any questions? Any other questions on number 4?
So, miss, when I say like that, and you say 2 into 5, you just divide it in 2.
Yeah, if you, well, the answer could have been, one of the choices could have been 5/2 x, but it wasn't. So now you got to divide it out and see if, oh, that's 2.5 or 2.5. So my answer can only be A.
The reason why I choose B is because I multiply.
You
Right.
multiplied.
I said 2, 5, 10.
Yes, but you just, Mercedes, you took that division sign and made it multiplication. That's a division. Can't do that.
Okay.
Yeah, if this was division, then it would be 5 times 2 is 10, and 3 plus 2 is 5. So B would be correct if this were a multiplication, but it's not. That's a division sign.
So all I need was to do was to, when dividing exponent, is subtract the exponent.
That's right.
But multiply the coefficient.
Well, no, you divide the coefficient. Division means division. You divide the coefficients, divide the exponents. 5/2, exponent, subtract, x to the 3 minus x to the 2 is x to the 1.
Okay, thank you, Ms. Bauer.
Yeah, you do both. If it's a division, you do division of the exponents, division of the coefficients. If it's multiplication, you do like I said, if this was multiplication, you multiply 5 times 2, get 10, add the exponent 3 and 2, and you get 5. So B would be correct if it were a multiplication.
Okay, thank you.
Questions? Now, number 5, let's see. You put a question mark on that one, Mercedes.
I tried another.
And Maureen, you gave me 2 different answers, neither one of which was correct. Okay, now let me make this bigger, and then I'll give you a hint as to how you solve a problem like this. Okay, this is number 5. I'm going to the next screen so I can have all of this on one screen. Okay, this is number 5. Make that bigger so you can see it. Okay. Okay. Now, when you see an expression like this, 7 times square root of 5 plus square root of 20 plus square root of 500. Now, there's a little clue in here that tells you what to do. Does anybody see what it is?
That little clue?
Yeah, there's a little clue here. Does anybody
Yes.
see it? What is it?
Okay, it's saying multiplication. No, it's a
No.
5. It's a 5.
Yeah, the 5 is the clue, the square root of
Oh,
5.
the 5.
When you see
Yes.
this square root of 5, you think to yourself, ah, what are some factors here? I can get a 5 out of 20 and out of
Okay,
500.
so would they, if you get a test like that, Miss Barbara, would they put it like that?
What do you mean put it like that?
No, you said that's a clue.
Well, the clue here to simplify this is what can I do with my square root of 20 and my square root of 500 to get a square root of 5?
So is a hint that?
That's the hint. That's the
Miss
hint.
Barbara.
Yes, the
Oh,
hint
you're
is,
a math whiz.
the hint is, what are the factors of 20 and of 500 that will give me a square root of 5?
Okay, miss, I'm looking at my,
Don't talk to you.
and I did start divide out 500 with the 5, so I had to break it down. And I reached a 20 and I stopped.
No, see, you already have 7 times square root of 5. So let's just take our square root of 20. We'll take that one first. Now, Alva, give me 2 factors of 20. 2 numbers you can multiply and get 20.
2 tens?
10 times 10 is 100.
No.
I
Oh,
said
okay.
multiply.
Oh, multiply.
2 numbers you can multiply and get 20.
Okay, 5 and 4.
That's it. Perfect.
Yes.
20 equals 4
And 5.
times 5.
And I got
So
my-
if you can do that, you can take this radical and make it square root of 4 times square root of 5. So let's just put here square root of 4. Put that one first. Reason I'm putting that first because that's a perfect square, right? And that's square root of 5. So let's make this 5. Okay. So now I've got square root of 20 is square root of 4 times square root of 5. Now, Alva, what's the square root of 4?
16. No. 4, 2.
2, that's right.
Yes.
Because
Yeah.
2 by 2 gives 4. So we
Yeah.
can take this and put it as, okay, here we go. Then we put our 2 here. Now we've got a 2 here. And we don't need this radical because now we took the square root of 4 and got 2. Everybody follow me how we translated the square root of 20 into 2 times the
2.
square root of 5.
Yes.
Any questions on that step?
No.
Well, a minute. Question there, right there, right?
Yes. What's the question, Melissa?
I got that part. I have 20 equal.
You got the 2 times the square root of 5?
No, the top one I'm talking.
You got the
20
square.
equal, right? I got it right there, miss.
But what's the square root of 4, Mercedes?
I didn't know I should go further.
Well, you have to. Remember, it says simplify.
Yes, so you have to go to the last.
So you got to get the square root of the 4. And now the coefficient of that square root of 5 is a 2.
Okay.
Okay. So any questions on the square root of 20?
No, miss.
No.
Okay, Maureen. Maureen, are you there?
Yes, Miss Barbara.
Okay, now let's go to 500. Okay, what 2 numbers can you multiply to get 500, Maureen?
100 by 5.
100 by 5. Okay, so you have 500 equal 100 by 5. Okay. All right. So if I can do that, I can also take this square root of 500, make it square root of 100 times square root of 5, right? So let's just put that, copy that here. Now we can factor this into two radicals. One is 100 and the other one is what? 5. All right. Okay, what's square root of 100, Mercedes?
20.
What is it?
Square root of 100. 20.
Square root of 100?
Square root of 100 is 5.
You were about to say it correctly. Why you changed it? What number multiplied by itself to give 100?
10.
10. You were about to say it. You didn't say it. There you go. So that's 10 times square root of 5. So now you can see your answer. Anybody see the answer?
Hold up, miss. I need to know why. Why
The answer is B.
The answer is what?
B.
What did you say, Maureen?
B.
No, where you get the
Oh.
square root of 3 from? What did you say? I'm sorry.
I said B.
D is in dog. That's the answer. Anybody see how Maureen got D?
no.
She took the 2, the 10, that's 12. We already had a 7, that gave you 19.
Miss, I go to 19. I couldn't beat it. I can't figure it out. Miss, I don't
Okay.
understand part of it.
Okay, so
Because
let,
I choose 19. I take the 19 and I start to see if I can work it back to 500 and I
okay.
can't.
Okay, so let me just put this here, since we broke it down for each ones that didn't have the square root of 5. Okay, so we'll just put square root of 5. Just copy that again. Now the square root of 20, now go back up here. Square root of 20 is 2 times the square root of 5. So now this becomes 2 times the square root of 5, because you saw where I translated that, right? So this is a 5. That comes out. The 500 is 10 times the square root of 5. So this is 10 times the square root of 5. Now all you need to do is just add the coefficients. 7, they all have square root of 5, right? So you could add 7 plus 2 plus 10. Okay, so 7 plus 2 plus 10, and that gives you what? What does that give you, Maureen?
19.
19. So now your answer is 19 times the square root of 5, and that's answer D right there.
So Miss, how would you work out that to get 500? It says
Miss Barbara,
Yes.
my television just blacked the face of it. I'm not seeing one thing. I don't know what happened.
You don't see the screen at all?
No. I'm hearing you, but I'm not seeing anything.
Okay.
I don't know if it's. Let me see if I can pick you up back on my phone.
Okay. Now, Mercedes, what were you saying about the 500?
how do I work it back when you have 7 plus 2 plus 10 give equal 19, you say? How on earth do I work it back to 500?
Okay, but remember, I
Because
took.
I
Okay.
didn't know that I could had 7. I've been looking at them and looking at what I work out almost the same as you, but I just couldn't return it back to 500 to prove it because I didn't know I could use a 7.
Well, it's a coefficient. If you had 7x plus 2x plus 10x, you could add and get 19x, right?
Okay.
So if you had the 7 and the 2 and the 10, all coefficients of square root of 5, you can just add them up. It will be 19 times the square root of 5.
19 times. So you're gonna that would give multiply 19 5 times to get 500. That's what you're saying?
No, no. I'm saying we took the 500 and
Yeah.
factored it into two radicals.
Okay.
One had a perfect square root. 100's perfect square root is a 10. So square root of 500 became 10 times square root of 5, right here.
Hold on. So the square root of 100
It's
became
10, right here. You see
Right.
that?
Yes, I just see it.
Okay, so that's 10 times square root of 5. And square root of 20 was square root of 4 times square root of 5 became 2 times square root of 5. So you understand how we're getting the coefficients?
I understand you get the coefficient for 20.
But you don't understand how we got it for the 500?
Yeah, because I just
Okay,
I'm
right here. I'm on the other side.
Yeah.
Square root of 500. Well, Maureen told me 500 factors are 105, right? 100
got that little
times
part
5.
there.
Okay.
I got the part with right there right where you are. I got right there.
Okay. So square root of 500 is square root of 100 times square root of 5, because 5 times 100 is 500.
Good. I got that part.
Okay, but what's the square root of 100, Mercedes?
That would be 10.
10. So there's my 10. So this is 10 times square root of 5. Question?
10 times. So how would I multiply it back to get 500?
You don't want to multiply. You're trying to add these. You're trying to add these, right? The original problem said 7 times square root of 5 plus square root of 20 plus square root of 500. This is an addition. So what we did, we translated our square root of 20 and our square root of 500 to a coefficient and the square root of 5. Because in that case, then we could just add the coefficients.
Oh, because all of them are over 5.
All of them are in front of the square root of 5.
Yeah.
They're coefficient, not over. Coefficient comes in front of the variable.
Oh, yeah.
But here the variable is a radical, square root of 5.
So,
See, the original problem is an addition. See, simplify the following an expression. This is an addition.
Excuse me, Miss Barbara, are you on YouTube?
Well, I will be putting it on YouTube at the end. I'm recording.
Okay. I don't know. I'm not seeing any.
Okay, I'm recording. You don't see it on your phone?
No, I'm not getting it on the phone.
you go to
And the computer just turned dark. I don't know what happened.
Okay.
Did you go to Zoom? Did you try Zoom?
Oh, Zoom.
Yeah, you just go to Zoom on your phone and then put in the number, the code.
Oh, she could go to her email and click on the link. Go back in.
Okay, let me try my email.
Just go to the email Miss Becca sent you and then click on the link.
Okay.
In fact, you could try that on your computer. Maybe it'll work.
I don't know, it's just black. I'm hearing you, but I'm not seeing.
Well, you could try, go back in again, Alva, on your computer, because then it might clear up. Just click the link again.
Okay.
And then I might clear it up. Mercedes, did I answer your question?
I'm trying to get it. So I understand. Oh, you get the 19. But I
Okay.
didn't realize because the addition I should just do that because I go to 19 and say, what on earth?
Yeah, this is an addition. So we want to simplify this so we can add the coefficients. So I need a square root of 5 out of the square root of 20. I need a square root of 5 out of the
Oh, it
square root
came
of
back
5.
now, Miss Barbara.
Very good. So now you can
Yes.
see the screen, right?
Yes, yeah.
Alma, did you follow how we simplified this expression?
That's the same math you were doing.
Yes, we're still on number 5.
Yes.
So I said your clue here was your square root of 5 as your clue.
Yes.
So you think to yourself, what can I factor with my 20 and get a 5? What can I factor with my 500 and get a 5? Because if I can get a 5, then I can get a square root of 5. Got it?
Yes, ma'am.
So
Yeah.
the 20 we factored into, you told me 4 and 5. So that's square root of 4, square root of 5. Square root of 4 is 2. 500, Maureen said 105. So I can make square root of 500, square root of 100 times square root of 5. So now I've got all of them with coefficients of in front of a square root of 5. And once I have them all the same, I can just add the coefficients. 7 plus 2 plus 10 is 19. So the answer is 19 times the square root of 5. Questions? Any questions on number 5?
So all we're doing right there, Miss, was simplifying.
That's it. And when you simplify it, that means you can get coefficients. You can get the factor of the coefficient the same. That way you can add the coefficients. So that, like I said, the hint was the square root of 5. If I can make my 20 and my 500 factors include a square root of 5, then I can simplify it.
Miss, I simplify 500 to 20 times 25 and I get 500. And I'm here listening to it and you're saying that, so I said, oh, that part didn't work out.
Yeah, but if you take 25 and 20, you're going to have to do your 20 again. 20 factors in the 4 and the 5. You could work it out that way, Mercedes, but it'll be 2 steps, but it'll work. Okay? Because this 25 is square root, but then you had the 20, so 20 is 4 and 5, right?
Okay.
Questions? Okay, let's go to rationalize. Number 6. Now, Maureen, you had that one right. Mercedes, you did not. I wonder why. Mercedes, what? We only rationalize in the denominator. You remember the rule? What was the rule?
Number is this? Oh,
What was the rule for rationalizing the denominator? Making the radical or rational number. That's all we're doing. And how do we do that, Mercedes? You remember what I told you?
no, Miss, I'm sorry.
Maureen, you remember? Let's see, Maureen, you had it correct, Maureen. So what did you do? Tell us what you did.
I know what I know how I figure out like, cause you know we had do one Monday semester that one.
Okay, so tell me how you did it.
I put
Okay, I'll just
okay.
put here. Let's see, 2 times the square root of
I
5.
put 2.
Okay, let's put the square root of 5 here on the left.
Right. I put 5. I put 2 over 5. Right.
You did what?
I put 2 over 5 multiplied by 5 over 5.
You mean square root of 5?
Yeah.
Okay. Okay, let me just, okay. So you remember I told you to rationalize the denominator, you multiply both the numerator and the denominator by this radical, right?
Yeah.
So this becomes, let me just put, okay, that's, so I'm putting a multiplication here. So I'm using the asterisk for multiplication.
That's number 6.
Yeah.
Yes, So to rationalize, you multiply both numerator and denominator by the radical. So I put the square root of 5 times the 2. So I'm putting that here. All right. Okay. And then I put the square root of 5 underneath that because I'm multiplying both numerator and denominator by square root of 5. All right. Everybody with me? So that's your first step. Multiply numerator and denominator by the square root of 5. Let's just make that bigger. Okay. Any questions on the first step?
Okay, so the numerator, you multiply it by 5.
Square root. Radical 5.
Yes.
Alva, this is square root of 5.
Okay.
And the reason you did that, because see, you have the square root of 5 here. So whatever is in the denominator, you take that radical and multiply that radical by both the numerator and the denominator. So I have 2 times square root of 5, square root of 5 times square root of 5. All right. So what did I say when you multiply square root of a number or a variable by the same square root number variable? What do you get? Mercedes.
When you multiply this, please repeat that.
Yeah, when you multiply a radical by itself, what do you get?
You get a radical.
Get the radicand. That's right. You get what's under the radical. So square root of 5 times square root of 5 just gives you 5.
Yes.
All right. So this then becomes, so this would be equal, and we just repeat what we have here, 2 times the square root of 5. All right. And so what would I have in the denominator, Mercedes? What goes in the denominator right here?
5.
5. Very good. That's it. That's your answer. So Mercedes, what did you do with this one? Because you didn't. Let's see.
I was.
No, you get. Well, no, you gave me C.
I just guessed it.
Oh, you just picked one with the 10.
Yeah, I just guessed. Said 2, 5, 10, and this.
But you just told me when I multiply a radical by itself, you get the radicand, the number under the radical. So how did you get a 10 out of a 5?
Because I didn't remember to do the way I just thought.
Okay, but you just told me the rule, so but you didn't apply it. So Alva, I'm sorry, Mercedes.
I didn't remember the part of that rule. Sorry.
Okay. So when you multiply radical by itself, you get the radicand. So square root of 5 times square root of 5 just gives you 5. Square root of 100 times square root of 100 just gives you 100. Got it?
So the answer is B, miss?
Answer is B. Alva, you see that?
Yes, Miss Barbara.
Can you see the screen, Alva?
Yes, I'm seeing
Okay,
it
good,
now.
good. So 2 times square root of 5 over 5 is answer B.
Yes.
Answer
B.
B.
That's number 6.
Yes. Any questions on how you rationalize the denominator?
Can you repeat that sentence, miss? When you multiply.
When you multiply a radical by itself, you get the radicand. That means square root of 5 times square root of 5 just gives you 5. Square root of 10 times square root of 10 just gives you 10. Square root of 1,000 times square root of 1,000 gives you 1,000. Okay?
Okay.
That's why square root of 5 times square root of 5 just gives you 5. Whereas in the numerator, we have the number 2 times square root of 5, and that's just 2 in front, the coefficient of the square root of 5. That's your answer.
Thank you, miss.
Now, sometimes you may have to simplify. You may have to rationalize and simplify. But this one was just straight rationalizing. You didn't have to simplify anything. It's already simplified. Once you get it, 2 times square root of 5 over 5. That's as simple as you can get it. Any questions on rationalizing?
Well.
So
It
you
said
think you'll
yes,
be
but
able to do
sometimes.
it? You think you're able to do another one like this?
Excuse me, miss.
Yes.
What did you do to get the 2 on the 5 on top? Again, sorry.
How did you get it?
What do you do to get a 2?
Because
Right.
remember I say you multiply the radical by both the numerator and the denominator. 2 times the radical 5, square root of 5 times the radical 5. That's how I got 2 times radical 5.
So you just bring it back over in order. Okay.
Yeah, I just put the 2 in front and took the multiplication, because 2 in front of square root of 5 is saying 2 times square root of 5.
Okay.
Okay. Questions?
No, thank you, miss.
Okay. All right. Let's I want you to rationalize another one. Okay. All right, Abba, I'll give you a rationalization. You tell me what the answer is. Okay. 6. And I want to put this over. Get that square root of. Okay, let's see. I want to put that over square root of 15. Okay, Alba, I want you to rationalize that. What do I get?
Okay.
6 over square root of 15. I want you to rationalize it. Okay. Rationalize. Okay. What do you get, Alba? 6. Alba, do you hear me?
Yes, Miss Barbara, I'm here.
Okay. Rationalize 6 over square root of 15. Now you're going to multiply numerator and denominator by what, Alba?
You're going to multiply it by 6.
No. Remember I say the radical, you multiply numerator and denominator by the radical. So that means, let's go back up here. You see I said radical, multiply
Yes.
numerator by the radical, denominator by the radical. So what would this become, Alba? I'll put your multiplication here. We'll use the asterisk. So what do I multiply this by, Alba?
You're going to multiply it by the denominator.
That's right, multiply it by the square root of 15, right?
Yes.
So that's going to be square root of 15. Let me put the 15 here. Okay. Bring that back up. And then I multiply the denominator by the square root of 15. So let me just underline this. Put the square root of 15 under it. Okay. So let's put the square root of 15. Then, Alba, what do you get when you do that? This is a 15 because that's radical 15. So what do you get for the top one, Alba?
Okay. The square root of 15, 6. You're multiplying both of them with the denominator. The 6 with the.
I'm multiplying the 6 times the square root of 15 and the square root of 15
Yes.
times. So what do I get when they
Okay.
just say 6 times the square root of 15? What is that equal to?
6 times square root of 15.
That's right. That would just be 6. And we just put the square root of 15.
Yes, so I get 90.
No, you can't multiply a number by a square root.
You say multiply this 6 by 15?
No, that's radical 15. It's a difference now.
Okay, so you multiplying 15 by 15.
No, the numerator, 6 times radical 15. 6 times square root of 15. So you just put
Yes.
6 in front of the square root of 15.
Yes.
Now, what do I get for the denominator, Albert? What's the square root of 15 times the square root of 15?
Okay. 15.
What's square root of 15 times square root of 15, Albert? I just gave you a rule. What is it? Radical times itself gives you the radicand. So what's the number underneath the radical symbol?
Well, I get 225.
No. What is the number underneath the radical symbol? There's the radical symbol. What is the number here? What is this number right here?
15.
15. That's what you get.
Oh, okay.
Radical times itself gives radicand.
Radical 15.
Radicand is the 15. This is the
Yes.
radical symbol. This is the radicand. So
Okay.
the 15, radical 15 times radical 15 gives 15.
Okay.
Now
okay.
I said to simplify. Mercedes, how would you simplify it?
I would say 15 to 15, 1. I would have,
No, you can't. You don't have 15,
No,
15.
you
You have
could-
radical 15 and 15.
Yeah, if you simplify it, maybe you would have 3.
no,
No, Alva, you're on the right path. You divide the 3 into the 6 and the 3
Yes,
into the 15.
into the 15.
And what do you
yes.
get, Alva? What's 3 into the 6?
well, I know that
3 into 6 would be 2.
Okay, so that would be 2.
Yeah.
And
And
that's
3
time-
3
and-
into 15 would be 5.
Okay, there we go.
Okay.
That-
can I explain something?
Go ahead, Mercedes.
I know that you have 2 common factors that can divide 15 and 6, but I didn't think that you're gonna do it like that, because I'm trying to.
But that's what
Right.
simplification means.
Once you say simplify it, I bring it down to the lowest term.
Yes, that's right.
Yes,
You take
yes.
615.
Yes.
That's it, Alva. That's the way of looking at it. Reduce it to the lowest terms.
term.
3
Yes.
into 6, 2 times. 3 into 15, 5 times.
So you say 3 into 6, 2, and 3 into 15, 5.
That's right.
That's the reason why you put 2 and the sign with 15 over 5.
That's it. It's like you took the 6 over 15. Okay, let's say 6 over 15. And like Alva say, you simplified that to 2 over 5, right? Got it?
Yes, ma'am.
Mercedes?
Equal to 2/5.
Yeah, 2/5. So that's
Yes.
2 times square root of 15 over 5.
Okay, I'm getting it.
You got it?
Yeah, I was thinking it another way. That's why, but I understand the division section right there.
Okay. Yeah. The one we had on your
I under-
homework, it just said rationalize because it was already simplified. But I gave you an example here where you had to rationalize and simplify, because after you rationalize, you still had 2 numbers that could be simplified, the 6 and the 15, because they share a common factor of 3.
So
Right?
the six and the radical, what we call the sign again? Square, 15. Those are when you rationalize it, and then you simplify it then after.
Well, the rationalize is what we did here. Multiply both numerator and denominator by the radical. The simplifying is recognizing that you have 6 and 15 that have common factors of 3. So you
Yeah.
can simplify it to 2 over 5. Got it?
Yes, that's a question I asked. Yeah.
Yeah. Okay. All right. Now let's look at probability. And the probability, let's see, 7. Mercedes has 7 correct. And Maureen has 7. Okay, Maureen, I want you to explain number 7. Read it and explain it. Because you had it correct. And I want to know how you did it.
Okay.
Okay, let me
And
just make
drawing cards from a 52 card deck, any simple card has an equal chance of being drawn after 6 cards have been drawn. And what is the probability of drawing an ace of hearts if they have not yet been drawn? Okay.
So, how did you do that one?
How did I do it? Let's see. I do my like simple segment. I say like the possibility, right? That you draw okay. So I say the 6 cards, right? So it did 6 from the 52, right?
Okay.
And I subtract the 6 from the 52. I
Okay.
get 46.
All right.
And I get 46. So I said that it was only a 1 in the probability that you get an ace. That's how I do mine.
Okay, that's correct. Alva, you understand what Maureen said?
I'm not, I don't fully understand what she's saying.
All right, Maureen, give her
Yeah.
another explanation.
She says it's 52 cards in the deck.
Yeah.
Okay.
And what is the probability of drawing an ace?
So they said chance of being drawn after 6 cards
After 6 cards.
have been removed.
Uh,
So they got
after
52
6 cards.
card deck.
they draw 6 from it.
Yes.
So
So
how
you
many
left
do
like
you have
40.
left? How many you have left, Maureen?
Oh,
46.
48.
No,
46.
6 from 52, Alva.
Oh, 6 from 52. Okay.
Is
so
what, Alva?
6 from 50, leave 44. Leave 6 from 50, leave 44.
It's 52 cards.
Yes, but it said after you're gonna take 6 from 52.
Yeah.
Okay, so 50, you're gonna take 4.
No, just take 6 from 52, Alva.
Yeah, that's
Subtract
what I'm
6
saying.
Subtract 6 from 52. What do you get, Alva?
6 from 46, 48.
Which one? You said 2 numbers.
Okay, if you take 4 from 50, you'll get 46. And the 2.
Not 4.
Alva.
Yes, Ms.
Alva.
Barbara.
What is
Yes.
6 subtracted from 52?
How I do it, Miss Barbara? I said 6 from 50, leave 46 and 2, 48.
No.
No, 6 from 50 is not what you said. What's 6 from 50?
6 from 50, leave 44.
Okay.
And the 2,
Make it 46.
Let her finish,
Yes.
please, Mercedes.
Sorry.
Go ahead, Alva. Tell me again.
6 from 50, leave 44.
Okay.
And 2, so 44 and 2 is 46.
That's right. So 6 cards was taken out, drawn and
Yes.
removed. So that
Yes.
52 card deck became a 46 card deck, right?
Yes, yes.
Okay. So probability of an ace of heart, and you haven't gotten an ace, out of 46 cards, Alba? What would be the answer?
Would it be D?
How many cards do you have left?
46.
So what would be the answer?
Oh, okay. Now I understand. It would be C.
That's right.
Yes.
Now
Okay, Ms.
remember,
Barber.
yes, remember ratios can be used for probabilities, percent,
Yes. Yes.
fractions, decimals. Okay, so your answer would be right here,
C.
C. That's right.
Yes. That's number 7.
Answer C.
Yeah.
Yes.
All right.
Yeah.
Questions? Okay.
So that one now, if you get it on a test, all you do, you check up how much you listen to what they're saying and how many cards you're gonna take from the deck.
That's right. Because once you take cards and you don't put them back,
Yes.
you reduce the total.
It's like you subtracted.
That's
from-
right. 52
Yes.
minus 6 is 46. All right.
Yes.
Because it
Yes.
says drawn and removed. So you don't put them back. So you reduced your 52 card deck by 6.
Yes. So it's 1 to 46.
That's right.
Yes.
And
Okay,
it
Ms.
says
Barber.
the ace of hearts has not yet been drawn. So there's only one ace. So there's only one possibility, possible over total. That's probability. There's
Yes.
only one ace of heart in a deck of cards.
Yes. Yes.
How many, is everybody familiar with the 52 card deck?
I'm not really a card player, but I think they have 4 of each,
4 of what?
like the aces.
Yeah, they have how many suits? When you say suits,
Oh,
how many do you have? You have 4. And what are they, Alba? You know what they are?
No, it's
Okay, you have red cards, hearts, and diamonds. You have black cards, spades, and clubs.
Okay.
Each of those you have 13. So 4 times 13 is 52.
All right. Okay.
And within each suit, you have ace, king, queen, jack, 10, and then all the numbers.
Okay.
Okay. Because we will be looking at probability dealing with cards. I want to make sure you're familiar with what a normal card
I know
deck.
each deck of cards have 4 of each.
4 of each what?
Oh, like if you have ace of spade
Okay.
and the
Yeah, ace of spade, ace of
Yes.
club, ace of
Yes.
diamonds, ace of
Yes.
hearts. Okay.
Yes. Yeah.
All right. All right. Let's go to number 8. Let's see. Number 8. Okay. Mercedes, you didn't do number 8. Now, is everybody familiar with what a die looks like?
Yeah.
A die has 6 sides, right?
Yeah.
And each side has a number.
Excuse me, Miss Barbara.
Yes.
Didn't get my answers up to 10.
Yes, I got it. But you had number 8. You had 8 incorrect.
Okay. I just want to know you got that part. You saw it.
No, I got it. I got it, but you had it incorrect. Maureen had it correct.
Okay, so we are dealing with the same
Okay. Yeah, we're looking at number 8.
okay.
A 6-sided die. Now, a die has 6 sides, and each side has a certain number of dots. And it's 1, 2, 3, 4, 5, 6. All right. So let me, okay. So I want to see if you can figure it out. So die has 6 sides. And their numbers are 1, 2, 3, 4, 5, 6. Okay. Is that clear to everybody?
And 3 numbers
Okay.
A little bigger, Miss, please.
and
This is yeah, I'll make it bigger. Their, that would be their numbers. Okay, so a die has 6 sides. Okay, I'm making it bigger. And their numbers are 1, 2, 3, 4, 5, 6. All right. Now, Alva, of those 6 numbers, how many or 3 are greater?
Oh,
Oh, how many or
Alva?
3 are greater?
Yes.
So I would say
Look at these right here. Now tell me, because we're trying to find the probability of 3
do you understand the question?
or greater. Okay.
so it would be 4, 5, or 6. No?
No, you can't give me but one number, Alva.
Oh, just one number.
I said, how many
Yes.
of these numbers are 3 or greater?
Mm.
Look at 1, 2, 3, 4, 5, 6. You have 6 numbers, right?
Yes.
How many of these numbers are 3 or larger than 3? How many of those 6?
Okay, I would say 6. 6.
How many are 3 or greater than 3? How many of these numbers?
Are greater than 3.
3 or greater?
4.
4. That's right. 1, 2, 3, 4. So the probability that 3 or greater would be what? 4. That's
Yes.
possible.
Yes.
And the total, how many total sides are there for the die?
Okay, it would be 1, 2, 3, 4.
I gave it to you right here. How many sides?
6.
6.
Yeah.
And what would that be simplified, Alva?
Okay. 4
4 over
divided
6
by
simplified would be what?
2.
2 over what?
2 over.
Uh-oh, I know about it.
It would be 2, Miss Barbara. 2 over 1. 2
No.
over 2 over 6.
What number goes into 4 and goes into 6?
2 and 3.
Right. So 2 into 4 is 2 and 2 into 6 is 3.
It's 3. So it's 3/4. 2/5. 2/3.
No, 2/3. So
2/3.
what's the
Yes.
answer? There are your
Um,
answers over here.
where the answers is?
Right here on the other side. 2/3, 1/6,
Oh.
1/3, 1/2.
Miss Barbara, I wish my brain was younger. I would really take it in.
So what's the answer, Alva? Where do you see the
The
2/3?
answer is A.
That's right.
Oh my
Answer
goodness.
A.
Oh Lord.
Answer A. So
And it's so simple.
let's put answer
Mm.
A. I'll make
Because
that
you have
bigger.
4. I would appreciate. Oh, you said this is on my phone, so I have to look about. And when you go to take the test, it's only people who's really studied the math can pass it.
Okay.
Oh,
Mercedes, you understand now how you solve it?
Miss, when the question says, what is the probability of rolling
3.
or greater? It was meaning the next number to 3, which is 4.
No. 3 or greater. How many numbers of 3 or greater, Mercedes, on a 6-sided die?
Is 4, 5, and 6.
3 or greater. You got to include the 3. Doesn't it say 3 or greater?
Oh, so you have to say 1, 2, 3, 4.
Yeah.
3, 4,
5, 6.
Why? So we have to put 4 over 6.
Yeah, because you have 3 or greater. You got 3
It's a six-sided.
4, 5, 6. 3 or greater. 3, and then you got 4, 5, 6 that are greater than 3. So that's 4 possibilities.
Yes. So you're gonna put 4.
Mhm.
You say 4/6.
Right, and then simplify it to 2/3.
Right, and 2 going to 4 2 times.
And
And
2 into
3
6.
going to 6.
2 into 6, 3
2
times.
into 6 goes 3 times.
Mercedes, that answer your question?
Yes, thank you, miss. Thank you.
Okay. Now, do you know the difference between an independent and a dependent event?
I tried to guess that. I couldn't understand.
Well, I think we looked at some when we looked at some examples. When you have 2 events, one event does not depend on the other event, then it's independent. In other words, if you flip a coin, you have 2 possibilities. What are they, Mercedes?
Head or tail.
Now, if you flip it and get a head, and then the second time you get a tail, is that independent or dependent?
Dependent.
Nope,
Independent.
it's independent
Because
because
it's on its own.
yes, it's on its own. In other words,
Yes.
getting a head the
Yes,
first
it's
time,
on its own,
it doesn't cause you to say, well,
which is
I
not
won't get ahead the next time.
independent.
They're independent events. You have a 1.5 possibility of getting a head or getting a tail. And
Okay.
one does not, the fact that you got a head doesn't affect whether you get another head. So that makes them independent. And the same like rolling a die. If you get a 6 on rolling a die, that's independent of what you get on the second roll.
Oh, so Miss Barbara, it would be D?
No, separate spinners. If you spin a red on one and you spin a green on the other one, it's not dependent upon whether you got a red on the other one. They're independent.
Yes, I know it's independent because they flip on its own.
Right.
But,
And also the coin. If you flip a coin 3 times, I mean, getting a head on the 3rd time is independent of whether you got a head on the 1st time. Okay, but what about B?
Draw 3 cards from a deck without replace
Yeah,
the card.
we just went through the ones where we took out 6, right?
Yes.
So now the second time you take out something is dependent because now you have less cards to pull from. Okay, so if you don't replace the cards, then those are dependent. That's a dependent event because what you get on the second is dependent upon cards you have taken out from the first, because now you have less cards. So B is the dependent. You say which one is not an example of an independent, which means it's dependent. It's B. Now notice whenever you have something like without replacing, that's a dependent event.
Okay.
Whenever you see without replacing,
without
that's
replacing.
dependent,
Yes.
right?
Okay.
All right.
I did
So
first
nine.
answer was B, and then I look at it and says maybe not because he said you don't have to replace the cards.
Without replacing.
Oh, without replacing.
Without replacing, that means like when we had that 52 deck and we had what? We took out 6.
Yeah.
Now we have a lower total. Okay.
Because it's just simple because it is standing on its own.
Right.
Independent.
Mm-hmm.
You just like if you can do things for yourself, you don't need help.
Now let me ask you, if you don't pay your electric bill, what happens?
They will cut it off.
Disconnect.
Dependent or independent?
If you don't pay it, if you don't pay your bills,
yeah,
or if you don't have to pay it.
If you don't pay your electric bill, what does Con Ed do?
Well, they cut it,
They'll
so
cut it off. So so whether you have
And-
electric is dependent upon whether you pay your bill. That's a dependent event.
yes, either you want to
Right.
cut it off or you pay your bill.
That's dependent.
Yes, ma'am.
Okay. Whereas you say, well, I'm going grocery shopping and then I'm going to a concert. Independent, dependent.
Yeah, what did you going grocery shopping?
And then I'm going to a concert. Those
And-
independent or dependent?
Independent.
Dependent.
Why, Alva?
No, independent, Miss
They're
Barbara.
independent because whether you
Yes.
go shopping or the
Yes,
concert
and
is
you're going,
independent
yeah,
of each
you're
other.
We
independent.
do what
Okay.
you want.
Yeah, I'm trying to give you some real world examples
Yes,
of
yes,
independent,
ma'am.
dependent.
Yes, yes.
All right.
So let's go back to B, Miss. So
Okay.
join 3 cards from the deck without replacing it is not dependent because you still
No,
can go back.
no, it's not independent,
It's not
which
independent.
is not an example of an independent. That means it's a pick the dependent event,
So
right?
which is an example of independent.
So if you're trying to get a certain card from a deck and you take out some cards, right? Then what you take out on the second is dependent upon what you took out the first, because now your total is less.
So you have to depend on the card part by keep going back to get the number you want.
Well, let's put it this way. Your chances, your probability of getting something is different once your total change. Because remember, your probability is the possibilities over the total outcomes. So once you take something out, you don't replace it, your outcome is different.
Okay.
It's smaller, right?
Yeah.
So that makes it dependent. Like when we went through
That's the thing I was saying, but I say it another way.
yeah.
So I understand. I understood what you're saying.
Okay. But just the key now, once you see replacing, it's got to be dependent.
Okay.
All right.
Thank you, Miss.
Now let's go to number 10. Let's see, number 10. Maureen, number 10. You didn't get that one right, but I think you can get it right. Okay. Let's go to the next page. Maureen, I want you to read number 10. You didn't have it right. Mercedes didn't have it right. But I think you can get it right, Maureen. Let me make this bigger and you tell me what the answer is.
Confusing to me, Miss.
The paper bag contains 3 blue marbles, 2 red marbles, 4 green marbles, and 1 white marble. Before replacing, what is the probability of drawing a red marble on the first attempt and a green marble on the second attempt?
Okay, now remember we went through these and I said, find the probabilities of both, right? Now, this is an independent event because it says without replacement, right?
Oh,
Okay, so Alva, what's the total number of marbles? You're gonna help Maureen get this right.
Okay, say a paper
What's the
bag
total? What's the
contain-
total marbles?
Oh, the total is 3 and 4, 7 and 2, 8, 7, 9, 10.
Okay, so total marbles is 10.
okay.
Yes,
So that's your outcome, 10,
Yeah.
right?
yes, ma'am.
Okay, now let's write probability. So we want probability of getting a red. So I say probability of red. Okay. Maureen, what's the probability of a red? Possible over total. So what would that be, Maureen? What's the
1 over-
probability of getting a red?
1 over 10.
How many reds are there?
2.
There's 2.
So where are you getting 1 from, Maureen? So
Oh,
what would it
Two
be,
over 10.
Maureen? 2 over 10.
okay.
All right.
Uh,
All right. So without replacement, we took a red on the first attempt. Now we want the probability of getting a green.
Yes, so it would
So
be,
this would be probability
before.
of getting a green. Okay, let's put green. What would that be, Maureen? What would it be?
4 over 10.
But if I didn't replace it, how many
Only
totals do I
replace it.
have?
1, 3,
No, Maureen. How many marbles do I have left if I took one
8,
out?
8, ma, 8.
I took a red out, Maureen.
Uh-huh.
How many do I have left?
Oh,
1,
got it.
Left, Maureen.
Left.
I had a
9.
total of 10.
Yeah, but you take up 1 away.
No, Maureen.
Mm.
Listen to me, Maureen.
Okay.
I have a total of 10 marbles.
Uh,
Okay. I took out a marble.
Oh, a
I
marble.
didn't replace it.
Okay.
So how many do I have left, Maureen? How many marbles?
9.
9. 9. Right?
Uh,
Miss,
So
one question.
yes.
It's 2 red marbles
yeah.
and you take out the 2. So
No, she said she took 1.
hold on, let me read
A
it.
red marble. I didn't say I took
red
a 2.
marble.
What's the
Yes.
probability of drawing a red marble?
One second, let me look at it.
A red marble.
Oh, now I see. Let me underline that sentence.
You see, a red marble
Oh, we
on
signify
first
one.
attempt and a green marble on the second. So probability of red is total red over total outcomes. And that's the total number of marbles that Albert told me is 10, 2 over 10.
So that's a-
Probability of green, once you take a marble out, you no longer have 10, you have 9.
9.
And you have 4 green. And so that would be 4 over 9.
9.
Now, Maureen, how do I find the probability of green, of probability of red and green? What did I tell you to do? So I want probability of red and green. Red on first attempt, green on second attempt. What would that be equal to? What did I tell you to do with the probabilities? Multiply,
Add them.
right?
Yeah, multiply.
So that would be probability of red multiplied, let me just put asterisk, times probability of green. What's that equal to, Maureen?
Red is 2, right?
No.
Red is 2.
And green is 4.
And green
No,
is
2
4.
over 10.
Oh.
No, these are
4 over
fractions.
10, yeah.
Okay.
And 4 over 9.
So this would be 2 over 10. Let's put this one because we found that probability first. I said you find the separate probabilities first. So that's 2 over 10 for that
4 over
probability
9.
and 4 over 9. What's that equal to, Maureen?
Oh. Okay.
What is that equal to, Maureen?
10 over 6 over 19.
Oh,
You adding, you're supposed to be multiplying.
Oh,
So 2 4s is
8 over 19.
Okay, so you got 8 over 90, and that's equal to what?
8 over 19. 8 over 19.
What's that equal to? Simplify it. What do you
It
get?
would be C, Miss Barbara. Would it be C?
Maureen, is that correct?
Let's see.
8 over 90, Maureen?
Yeah,
What is that equal to, Maureen?
9/8 is equals to, uh, okay, divide 2 into 8 and 2 into 90, you
So
get
what do you get?
45.
So what's
See,
the answer, Maureen?
see,
So, okay, what's the fraction? 8 over 90 equal what?
fraction was divided by 2.
Okay, so what 8 over 90 reduces to what?
No, the fraction, you have to go to the
Oh, wait,
last.
wait, wait. I just want to hear from Maureen. 8
Okay.
over 90 is what, Maureen?
4 over 45.
4 over 45. And
That's
that's answer what?
See,
Albert
So-
said it. Yeah.
Yes,
yeah.
C, yeah. Oh, I did say it, Miss Barbara, as I
Yeah, I
look
know
at
you
it.
said C. Yes.
Yeah.
So when you have two events, what do? You find the probability of the first event, probability of second event, and then multiply.
Yes,
But remember, when it says without replacement, your total is reduced by what you took out.
yes.
So you took out a marble. So now instead of 10 total, your total outcomes become 9.
Miss,
Yes.
I just don't understand how you get a 90. But let me see.
What's 2 times 4 is what?
8.
And 10 times 9.
Oh, that's how you do it.
Yeah.
You see,
You
You're
what-
multiply
going-
the, well, fractions,
what-
you just multiply numerator, multiply denominator.
Denominator.
Guess
Yeah.
what, miss? Sometimes I have to write it, but when you slash it, sometimes it fool me. That's why I make an error.
Yeah, but you
So
gotta
if I
remember
don't-
with the slash, the first number is the numerator, the second number is the denominator.
So now that I wrote,
Because
write it,
you'll see it on problems sometime. I do both ways, right? You see the answer here is 3/5, 3 over 5. So all you have to do with the
So-
slash, Mercedes, is the first number is numerator, second number is denominator.
so miss, when you have an 8 over 90, hold on a minute. Yes, you divide by the top and bottom by 4.
No,
by 2.
2. Tell her,
That's two.
Maureen, what did you do?
You said 2 into 8 is 4 and 2 into 90 is 45. Because 45 or 45 is 90.
Okay, got you.
45 times 2 is 90. Got it?
Okay,
Questions?
thank you.
No,
All
so
right.
if I had to get more, these days I won't forget nothing now.
Okay.
I
Now,
I did my verb.
I want to do one more probability. Well, not probability. I really want to go through. Okay. Okay. Dependent, independent events. Okay. Now, you see the bag here, right?
Yeah.
Has 6 red tiles, 4 green, 3 yellow, and 2 blue. See the colors right here, but I put them over here, and that's a total of 15 tiles. Now, for a simple event, you just take the color and divide it by the total. So Alvin, you see these tiles, right? 6 red, 4 green, 3 yellow, 2 blue. Total of 15. Alva, what's the probability of getting a yellow? Just tell me in words.
Okay. How many yellows you have? The bag
3.
went down.
3 yellow.
3 and 3, 6 and 2, 8.
Can I bring it
And
back a
4,
little bit? Miss?
12. It is 12.
What's the problem, Mercedes?
Can you bring the bag up a little bit, please? I'm sorry.
Okay. Well, I have the colors over here on the
Thank
right.
you.
Okay, 2, 4, 6.
I have the colors over here.
10,
6
11,
red,
13,
4 green. I
15.
wrote them again. 3
I
yellow
saw you.
and 2
I just
blue.
saw them here.
Okay, Alva, what's the probability of getting a yellow tile?
Okay, probability of getting a yellow in all is 15.
Possible over total. That's what probability is. How many
Yeah.
yellow are there, Alva?
3,
3. What's the total?
15.
So what's the probability?
3/15.
Very good. 3/15.
Yes.
Mercedes, what's the probability of getting a red?
6/15.
6/15. Okay. Maureen, what's the probability of getting a green?
4/15.
Okay, so we've got them all right here. They're the probabilities. All right. Now, those are the simple events. Now, if you draw two tiles at the same time, those are what we call compound events. And that's where you get dependencies, a dependent event. All right. Now,
Excuse me, Miss Barbara.
yes.
Is it possible to make the read a little bolder, please? Not that big, but a little bolder.
Okay. I have it actually bold. I'll just make it bigger. Okay. That better?
Thank you.
Okay, let me just make it better because I'm going to a compound event. The simple, you understand, right? You just take the color and put it over the total. But I want to look at some compound events where you have one event that will be dependent on the other. Okay. Okay. Let's go to, okay. Now we want to take two tiles out. All right, let me bring this up and then I'll make it bigger. Okay, so let's see. Let me make this bigger and I want you to understand how you're getting these totals. Okay, 22. All right, now, actually it's going over the other side, but the first event, the red, you have what? 6/15. But to get a green, if you take a red out, you no longer have 15, you have 14, right?
Yeah.
So the green, you have 4, and it won't be over 15 because you've taken out a tile, right? So that's 14. The same thing if you had red and yellow. Red, 6/15. Yellow will be 3/14. Okay. And then say a green, 4/15, then 2/14. Now, if you want to calculate getting the red and the blue, then you have to do what we call multiplication. All right. So green and blue would be green probability times blue probability. Remember, see, that's a 14. Okay. Questions on two events. That's what I had told you before. When you take one out, when you take one out and you don't replace it, you decrease your total.
Okay.
Okay. Now I want to look at let me just go to and or. Okay. Now we're looking at a splitter. There's some key terms I want you to know. When you see mutually exclusive, that means they cannot happen together. In other words, you can't get a head and a tail of a coin.
Mutual exclusive event.
Mutually exclusive. All that means is your choices can't happen together. In other words, a good example is a coin. When you flip a coin, you can't get a head and a tail together. You either get a head or you get a tail, right?
Yeah.
So that's a mutually exclusive event, flipping a coin, because you can't get head and tail together. And it's like spitting a spitter. Like here you have all these colors. You can't get yellow and blue at the same time. You either get yellow or you get blue. If you get like in between, you just spin again. Okay. Now,
can you just hold it there? Let me write down the definition.
okay.
Mutual exclusive.
Mutually exclusive. Well, remember, Alva, I'll be sending you this session.
Oh, you're going to send
I'll
it.
email this to you.
Yes, Miss Barbara.
Okay. But what I want you to remember with mutually exclusive events, all that means is they can't happen at the same time.
Yeah. Miss Barbara, is it possible you can send we can post them, post the readings like what you have here. Is it possible? Oh,
No, I send you this on your email. This is a session.
yeah, but I would love to have it in writing to read it and look on it.
Well, that's what I mean. What you see here is what you'll get in the email.
Now, I would say in the mail, if it's possible, the mail. Is it
Oh, you
possible?
mean the postal mail?
Yes,
Yeah, I can postal mail it. Okay.
please. Thank you.
Maureen, you need it?
Okay.
Okay, I can send it to you and Maureen. Make a note here, postal mail probability. Now you see a spinner. How many colors do you see?
All right, let's see.
10.
Colors.
One, 2.
10 colors.
I don't
Eight.
see
No.
10 colors.
8 colors.
1, 2, 3.
How many colors?
No,
4 colors, Miss Barbara.
4 colors. Thank you, Alma.
Yes. Yeah.
I thought you meant in all.
No, I didn't say
that's what
that.
I meant. I
I
thought
didn't-
that's what I
What
meant
did I
too.
say? I said, how many colors do you see?
Oh,
I'm at all
You have
pieces
an orange, a yellow, a red, and a
and a
blue.
blue.
4 colors,
Four
right?
colors.
But
Yeah.
the outcomes, you have 10 because you
Yes,
have 10 different places where you
Right.
have these colors. So the
Yeah.
total outcomes on the spinner is 10.
Okay,
You
yeah.
see
You're
4
right.
yellow, 3 red, 2 blue, and 1 orange. I put them right here for you. All right.
Thank you.
Now,
Merci.
what's the probability of getting an orange, Alva?
Okay, it's just one orange I saw there.
So what's the probability of getting an orange? Possible over total. Just tell me in
Okay.
words. It would be P equal what?
Okay, so it would be 1, 2, 3. 1, 2, 3, 4. It would be 1/4.
What's
No.
the total?
The total colors.
Not the total colors, the total
Oh, okay, Miss Barbara.
possible
Yes.
places on the
Okay,
spinner.
1, 2, 3, 4, 5, 6, 7, 8, 9. So
No,
10.
10. I've
Yes.
got it right here for you. 10 total outcomes on the spinner. So I ask you
Yes.
again, Albert, what's the probability of getting an orange?
It would be 1/9.
No.
How
Yeah,
many?
it's only one orange there and it's 10
Yeah,
colors.
but it's 10
Places.
possible here. It's 10 places you can go when you spin. That's the
Yes.
total outcomes. That's a 10, not a 9.
Yes, it's 10, Miss Barbara.
So what's the
But you-
probability of getting an orange?
1 out of 10?
That's it. 1 out of
Okay,
10.
I understand now. 1
You're
out
right,
of
because there's only
yes.
one orange. So if you
Yes.
spin this spinner, the probability of getting an orange is 1/10.
Out of over 10.
What about yellow, Albert? What's the probability of getting a yellow?
It would be 4/10.
Very good. You got it. What about a blue?
2/10.
And the red?
3/10.
Very good. I just want to make sure you know the simple events, right?
Yes.
Now, if we said yellow or red, you get the probability of the red, the probability of the yellow, and then you add them. That's called the addition rules.
Okay.
Okay.
Oh,
So,
miss, question right there, miss.
yes,
So if you ask what's the probability of
a yellow or red.
red, you put
So
those,
what
you
would be
had
your
it.
answer?
So you said what color? Yellow and red?
Yes. Yellow
That-
or red.
Yellow or?
Yes.
Oh no, that would be
Yellow or red, that's when you use the addition. So yellow is 4/10, red is 3/10. When you add them, you get 7/10. You got it?
But you know why I sort of think back, Miss, because you say or, so I'm wondering, should I not worry to add them together?
Okay. Probability of A or B is probability of A plus probability of B. There we go. 4/10 plus 3/10, 7/10. because you can't get them at the same time. That's why we call them mutually exclusive. You can't get a red and a yellow at the same time. You either get one or you get the other. That's the
But
addition.
that's why you have to add them together, miss.
You have to add the two together. The probability of getting one color or the other. Get the simple probability of the one color, simple probability of the other color, and then add them together.
Okay.
All right.
So you
Like,
say 7/10.
yeah, I got the 4/10. The 4 was what? The yellow. And the 3/10 was the red. So I add those two together and I say 7/10. That's the probability of getting a yellow or a red.
Okay.
Got it?
Oh,
And then you can do it for a combination of the other colors. All right, but there's one little, and I'll send you this. I've got these defined here: mutual exclusive, independent, dependent. And then I have a little flow here. You ask yourself, do they have to happen in the same situation? If yes, you use multiplication rule. If no, you use addition rule. When you get to the yes, does the outcome of the first event affect the outcome of the next event? All right. Then if it's yes, you have dependent. If no, you have independent. So you can just follow this and it will help you understand independent and dependent events. All right. Now there's some practice ones here. Maybe I'll just give you this for your homework.
Okay.
All right. Well, I have some homework for you anyway. But anyway, I'll continue this next time. This practice, we'll do these together. And then I'll send you, your homework will include both probability, rationalizing, because I want to make sure you understand that, and I think probably give you another scientific notation. Okay?
Okay.
Any questions on anything we've gone over?
Yeah, well,
To review some more.
I get a lot today from the class.
Yes,